So, beyond the two standard forms for the straight line that we've seen, the one that passes through the point with coordinates h, comma k and gradient or slope m, and the general form for a straight line written as a linear equation, ax plus by plus c equal 0, here are some other forms. So the one that you're most familiar with, which we will use quite often, is that where the fixed point hk that one is told is actually the intercept of the straight line with the y-axis. So hk now becomes 0, c. 0 for the x-coordinate, c the intercept for the y-coordinate. That means in the equation that we've just had, we're replacing h by 0, k by c, and on simplification that gives us y equal mx plus c, the equation of the straight line that passes through the intercept 0c, gradient m, or the straight line y equal mx plus c with gradient n, intercept on the y-axis of c. All straight lines can be written in that form except those which are parallel to the y-axis, which have infinite slope, and they will have form x equal constant. Now, one useful equation of the straight line is where, rather than given one point and the gradient, one is told two fixed points on the line, so that the straight line that passes through two fixed points. If we take those two fixed points as P1 and P2 as shown, and P being the general point on the straight line, it means that the formula we had before, which was y minus y1 is m times x minus x1, can have the m, the gradient, replaced by the gradient determined by the ratio of the opposite side to the adjacent side in any right angle triangle, but in particular the right angle triangle formed by the points P1, P2 that are fixed and the perpendicular. In other words, m is y2 minus y1 divided by x2 minus x1, and so the equation of the straight line that we had before simplifies to this, or on rearrangement we have this, which is the obvious fact that the gradient as determined by the two fixed points P1, P2, which is this ratio, is the same as the gradient of any line segment starting at P1 to a point P, which is this ratio. One form that we won't use that often, but you will see in some examples, is where the two fixed points that we're talking about are the intercepts of the straight line with either the x-axis, for which the y-coordinate is 0, and the x-coordinate we'll assume is the value a, and the intercept on the y-axis, for which the x-coordinate is 0, and we'll assume that the y-coordinate is b. That means the form on the previous slide can be replaced by x1, which is going to be a, and y1, which is going to be 0, and x2 is going to be 0, and y2 is going to be b. That means one gets this equation, and on rearrangement we have this nice simple form in the box. And so x over a plus y over b equals 1 is always the equation of the straight line that has intercept a 0 on the x-axis and 0b on the y-axis. And it's very simple to establish that if you make y equal to 0 in here, it gives you x equal a, which is this point, and if you put x equals 0 here, it gives you y equal b, which is this point. And once you've got 2 points, you have a straight line. Now, for many of our loci problems, we need to know an expression for the point, which is the midpoint of any line segment. And after a little bit of calculation, we can easily show something that you're all familiar with, which I've done up here, which is that if you take the point P1 and point P2, then the coordinates of the midpoint of that line are a half the sum of the x coordinates of the two endpoints of the line, comma, a half the sum of the y coordinates of the 2 points at the end of the line. If you want to check the details of where that comes from, you can read the top of this slide, but you don't need to know that. All you need to know is this formula in the box. So the coordinates of the midpoint of any line segment is the arithmetic mean of the x coordinates of the endpoints, comma, the arithmetic mean of the y coordinates of the endpoint. Now we move on to something slightly more interesting than the straight line, which is the circle.